Cast is now starting. All attendees are in listen-only mode.
Hi everybody, this is Sharon Hewson at AEE. Welcome this afternoon. We have Mr. Keith Waters with us today. I will give you a brief introduction to Mr. Waters before I pass you over to him. Okay, so Keith Waters is an industry-based standards manager for Schneider Electric USA and is based in Lexington, Kentucky. He is responsible for overcurrent protective device and automation, control, product standards, installation codes, enforcement, and holds a BSEE degree from the University of Kentucky. Keith's also engaged in applying codes and standards addressing energy efficiency and sustainability. Keith participates in the Power and Energy Institute of Kentucky's Industry Advisory Council, and he is a licensed professional engineer and a certified energy manager. Keith's been with Schneider Electric for about 32 years as a product application engineer, a proposal development engineer, a price manager, a merchandise marketing manager, and has held multiple business development positions, including strategic and global account management, as well as managing several strategic segment engineering teams. Keith is a frequent speaker on a variety of topics, including energy efficiency, sustainability, product application, and code compliance topics. Keith is a member of multiple industry technical committees. He is an NEMA, National Electrical Manufacturers Association representative to NEC Code Making Panel 11, and he has published articles on energy management and electrical controls. So I will go ahead and pass you over to Mr. Keith Waters, who's going to talk about building analytics to improve efficiency, sustainability, and financial well-being.
Okay, good afternoon, everyone. Sharon, can you hear me okay? All right, so.
Yes, I can hear you.
Okay.
Sorry, Keith.
All right, I just wanted to make sure we had the transition went well. So good afternoon. As Sharon said, thank you, Sharon, for the introduction. My name is Keith Waters, and I'm with Schneider Electric. We're going to discuss today building analytics and how you can use those to improve the efficiency, comfort, and financial position of your buildings. So we're going to go through a few things here. We're going to talk, we've done the introduction. We're going to talk about objectives, a little bit about know your building, fault detection and diagnostics, proactive and preventive maintenance. We're going to do a demonstration on what building analytics looks like, what it can do, what it can offer. Sometimes actually seeing something in action can provide a much better picture than just showing a screen capture on a slide. So, and then as anyone has any questions as we go through this, feel free to put those in the question box. And if someone has any issues directly with the connection or with the viewing any of the slides, please put those questions in the chat box directly to Sharon, and she will work on that. So when we finish today, you should be able to identify opportunities to utilize building analytics. What is fault detection and diagnostics? Ways to improve building and energy efficiencies. And you'll be able to determine how to implement building analytic solutions, how to read and understand fault detection and diagnostic outputs. You'll see me reference this in the slides as FDD. And then implement proactive and preventive maintenance. So first thing we're going to look at is know your building. So everybody that has some type of building, whether it's an industrial building, a commercial building, an institutional building, you have made an investment in some type of building automation system, metering system, HVACs, alarms, comforts, lots of different things that you've made investments in order to have your building operate. So, but did you know that that significant energy efficiency and operational savings can be missed without knowing the whole story? And what building analytics does is it converts the data that's created by those investments and puts them into an actionable intelligence, something that will allow you to go do something specific. So it's not just having an alarm go off and fixing it. It'll allow you to trend and look at things that you may not see on a day-to-day basis by looking at it over time. So when we think about critical facility drivers that impact any type of building or industry, we look at sustainability, new technologies, labor conditions, aging facilities, risk management, and outsourcing. And when we think of these in terms of buildings, we think in terms of labor conditions, in terms of how many people we have on site, what's involved with that, and then are they employees of the building management, or is it some type of outsourcing arrangement with a facility management organization? So you get a kind of a different piece no matter how you look at this. So this is one of the things that drives kind of what impacts different types of buildings, but they impact them very similar. Some may shift to one or the other, but in the end, they are viewing these same types of issues. One of the things when we talk about building analytics, it's not a replacement of a building management system. It's not a building management system extension. It is a complementary activity around what your building management system can do. So if you think in terms of a building automation system, you can talk about it integrates your building systems, your HVAC, chillers, airflow, any type of activity that you're controlling within your building. Okay, it's reacting to current state conditions, sensors, any type of pressure, flow, temperatures. It's reacting to those. It allows you to perform control tasks based on that. If your inflow of your air is at a certain temperature and it needs to be a different temperature, it creates an activity or an action. It provides notification of non-conformance of thresholds. Just what I said, right? You had temperature. So you have your temperature range. If it goes outside of that, you receive an alarm and you can go and see what the issue might be. A bad sensor, a stuck valve, whatever the problem might be. This type of information is ideal for day-to-day building operations. So as you function in a day-to-day building operation, that we can all get tied up in, this is what I have to do today, this is what I need to maintain my building, make sure that all the people in the building are having the right comfort, having everything that they need. Now, what can I do to take a different picture, something that gives me more information about expanding the knowledge and improving my building systems? And this is what building analytics can do. So it adds data analysis, allows you to identify reoccurring performance issues, provides return on investment prioritization for those issues, and it provides an ongoing support from an experienced building engineer. So when you think of building analytics, there's a couple of different ways you can do this. It could be, this is usually cloud-based activity. That can be some automatic activity from the data and the various software, and it can also be involved with a client support person being engaged with the building management facility manager and facility folks to review and provide that information. As we talked about the daily challenges of the day-to-day operations, you're looking at the occupant comfort, whether how complex is your building system, and that may vary from a commercial building to an industrial building to a hospital to a university campus, so it can vary. And then you have the potential shortage of personnel and operator training. So you might have an industrial facility, might have a lot of people on staff, and they may not, depending on the size of the facility and what their objectives are. And when you get into a commercial building, what you may have is someone who's involved with the overall building management, but maybe not be tied directly to some specific activity, whether it's building management system, energy management system, or something else. And then everybody's favorite topic is, what's available for the budget, right? And then not all buildings and systems deliver on their capabilities. So if you can have a building where you've put in all this nice equipment up front, but if it's not used, it's just nice equipment that's been put in up front for people to use. And then you need to be able to make return on investment decisions based on what's going on within the building. So when you talk about building analytics with fault detection and diagnosis. So whether you're talking about doing a diagnostic analysis from these faults, you're talking about prioritizing and asset optimization. You're getting an expert guidance, which in this case tends to be historical, being able to look at a broader view of the various buildings that are out there, right? You're not involved in just your building and what's going on there. You can now gather how does my building compare to other buildings of the similar size or of similar activity. And then the results that improve occupant comfort and energy and building energy and financial well-being. And then a lot of this information is based on statistical analysis, performance trending, and the diagnostics. So when we look at the two pieces of this, you have the software, which is a cloud-based solution that provides the fault detection and diagnosis. And then you have the remote monitoring, analysis, reporting, and maintenance, which is the client level activity that's provided. And when we talk about a cloud-based solution, we're talking about the software is not a resident of the building. So if you have a building or a campus or even a huge manufacturing facility, you're not hosting the software. You're not having to try to keep up with all of the updates and security patches and all of those types of things as it relates to those programs. Basically, the fault detection, the fault information, all of the data, it's a one-way push into the cloud, into the software to do that. There's no two-way activity there as it relates to the network. That's handled totally separately on the services side. So what can it find? So if we think about systems' ability to identify faults and opportunities for improvement. So some examples are on the right there. You see simultaneous heating and cooling, right? So if you've got heating and cooling going on at the same time, you're going to have an issue, right? You're going to use energy. You're going to have conflicting activities in process, and it's going to create all kinds of alarms. You have manual overrides. Someone has gone in to do maintenance and done a manual override and then not reset it back to the automatic setting. You could get into excessive reheating, chiller inefficiencies. We talked about stuck valves, leaking valves, broken dampers, static pressure issues, poor occupancy scheduling, whether that be HVAC, whether that be lighting control, whatever that might be. And then you also have the ability, if you notice reoccurring alarms or the duration of alarm, those are things that you can find, identify, and then analyze over time, which is what you're trying to accomplish here. You're trying to look beyond what's going on the day-to-day picture. So we talked about some of the common issues. We talked about the simultaneous heating and cooling. You have the issues related to energy performance. So you have the deviation of energy intensities from whatever your benchmark or baseline might be. Again, you may have a really nice energy monitoring system that provides information on what's going on time of day, kilowatt usage, all those kinds of things. But are you actually doing a baseline analysis along with weather, temperature, heating and cooling days to determine how your actual performance is over time and what it could be? So again, these are the types of things that will allow you to do that. And then the actual fault detection is determining if your cooling or heating system performance is not delivering what it's supposed to. then you run into some other things, right? We talked economizers, non-functioning sensors, lighting or other loads, and if you have any type of manual overrides, which we mentioned. So, or someone wants to go in and change the schedule, and anything that's out of the norm is the types of things that fault detection and diagnosis will pick up. So here's a kind of a simplified piece. So you have building 58 in a cluster E. You have various equipment, air handling units, VAV boxes. And then it gives you what the diagnosis was, the priority, and what the estimated savings would be. So what this is allowing you to do is to find the problem, make a decision based on the prioritization, cost, whatever your key decision point might be. So we talk a little bit about kind of how analytics, the process works, right? So when you think about the building data is established, then the data goes to analyzed, it's reviewed. The customer then gets an opportunity to review it, then provides the maintenance activities, what the reporting, right? What should be done, whether it's going to be done by an internal staff, by a contractor, excuse me, by some other type of service provider, and then active, then things are moved. So we talk about moving to the maintenance side for proactive, preventive, or condition-based maintenance. You're looking at analytics aren't alarms. They're not reports. They're the actual results that come from getting a clear understanding of what is going on inside the building. And it enables you to find patterns and issues that you might not be aware. And how you do that is, like any good analysis, let's look at the flow. We're looking at HVAC, chillers, air handling units, VAV boxes, system data, temperature, flow, pressure, what's going on from that. And then we have the FDD database of rules. So this is the database that's within the analytics, or whatever analytics package you might be working with. It provides that level of information on, all right, I'm going to analyze all this stuff, and what am I going to compare it against? And that's that historical database of all of the data that we've developed over time. So you compare the system data to the rules that are coming out of the fault detection and diagnostics. So is there a fault problem or no fault? No fault, everything moves forward. No issues, nothing to be due. If it does identify a fault, what type? What's the diagnostic information? What's the cost? And then we moved on for condition-based maintenance. This is involved in, historically, maintenance is done on equipment on a time basis. We're going to do maintenance on the HVA, on the air handling units once every 2 years. We're going to change the bearings on all of the chiller motors every 5 years. Whatever your time-based maintenance procedures might be, that doesn't say that something needs to be changed or is already failing and should have been changed earlier or replaced earlier. So what the condition-based stuff does is it allows you to predict the failures before they happen. So by utilizing the fault detection and diagnostics, it allows you to monitor all of these sensors, and then you can make determinations on, is equipment changing? So is the current draw on my chiller motors more than it was, indicating a potential issue with those motors? Is, am I seeing having to increase my temperature to maintain my level of comfort and the level of activities within the building? May seem to be, you could have a number of things, right? Could be sensors, could be blockages, could be failing components, but it allows you to do to use this to do the condition-based maintenance versus doing it on a time basis. It allows for better utilization of resources, better utilization of personnel, and also allows you to not necessarily be changing or working on stuff that doesn't need to have to be changed. And it allows you to get in front of things so you're not working on something after it's already failed and created a problem. So we saw a little bit about the flow. Now let's look at what the architecture looks like, right? So you have basically like any other software, you have web-based activities from reporting and data analysis so the actual data and stuff coming in from the building is not what's going out, but after it's all been analyzed, reported, and then the reports are available for usage by the various clients. Again, utilizing the cloud-based solution. So it's one thing to get an opportunity to see. So we've gone through some reasons why analytics are good, some things that analytics can provide for you. What we're going to do now is we're actually going to open up a demo site here to let you get a feel for some of the type of information that can be provided. And one of the things that's good is when all the connectivity works good. That's always a challenge when you're going to show something in software and actually go pull live data. Is will the connection work during the presentation? So and it has. So this is just a dashboard view of a building analytics software package that lets you put a building map in place. In this case, this is a global map. It could just as easily be this is a campus right here, so we'll dial it down. So this is a campus that's got 6 sites in the Boston area. So you could, so as you saw, you got different ways that you could see that. Then you come down and you have a few high-level avoidable costs, last month's diagnostic results, what are open tasks, what are open projects, building data points as a percentage of the various. In this case, you might be doing comparisons of various sites, of various buildings of similar type. In this case, you're doing it across countries. And then if you look to the left, this is the various things you can look at. You have your home page, you have diagnostics, an analysis, performance indicators, some commissioning, alarms, tasks, projects, so forth. So if we look at the diagnostics activity, so we talked about pulling all the data in. Now we can look at what that's going to give us, right? So you can select different building groups, date ranges, times, and then allows it to come in and give you the building, the type of equipment, what the analysis is. Here we got a heating plant energy issue. We have air handling unit coils, economizer. If we just take this top one, it looks like the boiler efficiency is low. So what's creating that? You get a number of tasks that need to be done to fix this, what the cost would be, and then a ranking. And so that ranking is based on the input. When you first are putting some type of an analytics package together, you're going to have the building input, and then you're going to be able to work with whoever's supplying your analytics opportunities to prioritize. So here's an energy prioritization. This is a maintenance prioritization, and so forth. So this one is based on energy. You can come over here and we can click on maintenance, and we'll get a different prioritization, right? So again, it's based on what you think that prioritization should be. for your buildings. So this one's on alarms. So it allows you to look at, where the alarms are, and are we within our acceptable band? Are we going below? What are our most frequent alarms? And is there a reason for it? So it gives you the number of occurrences, what building, what equipment. So if all of a sudden you're looking at, I've got Sydney, so I've got a building that's it's Sydney, and so they're all of these happen to be air handler 2. And then I start looking at the various alarms for air handler 2 and the number of occurrences. It might be that I need to make sure or obviously looking at what's going on with air handler 2. Then we talk about the length of alarms, right? So we talked about number of alarms. This could be the length of alarm. Is it something that, when your building management system created the alarm and it was acknowledged, did it come back? Was it something that was a long-term situation or something that was just identified and then moved on based on whatever the automation created was? And then also, here's one we talked earlier about people leaving manual overrides on. Okay, that's a very typical issue that occurs. This is a way to kind of view that and also determine, is it happening in different areas. Again, we got a reporting module that allows you to specify what type of reports you want to get, what type of charts. So it just allows you to select that. Lots of opportunity for determining how you want to slice and dice the data. So it shows you what you want it to see, what you need to see. So one of the things that we do is when you're developing a type of building, you have to do what your building profile is. So you're going to have to go through it. Is it an office building? Is it a laboratory? Is it some other type of situation? So in this particular one, this is an office building in Boston. Gives you address, information on it, right? And then what projects are going on with that building. So what the equipment is in that building and what it's been doing. Information on air handlers, boilers, cooling system, water systems, fans, heat exchangers, so forth. Same thing if you're looking at so here at Boston Air Handler, we're looking at Air Handler 3. So we're going to get an equipment profile for that specific air handler, right? And you have the ability, again, follow projects. You can also create documentation for that air handler. What are the, what's the manufacturer's installation and maintenance documentation. You could add that to this. So you could, down in the Documents tab, be able to create the access to all of that from this. Again, that's something that would allow you to not have to carry on-site documentation beyond what you felt like you needed. Here, we'll go back here and we'll look at performance indicators. So what we're looking at here is what are we expecting, right? What is our baseline? What are we going to do based on that baseline and how it's performing? You know, so in this case, we're doing a daily chart on avoidable cost for all equipment. So you can break it down looking at, you know, from a carbon perspective. Yeah, the chart's not there. One of the issues with demos is sometimes you have data added and sometimes it's not. There we go. So let's try that again. I didn't do it right. There we go. So here we were talking about cumulative carbon. So you have, this is your baseline, and then this is your, the green is what you're actually seeing, and then the various ways that you're looking at the analysis. Delta, trends, anything like that. Here we got, this one we're talking about avoidable cost for building performance. So if we look at energy, again, this allows us to, and we're doing comparisons, right? We're comparing multiple building locations, and we can see where the energy usage is. So again, we're performance. So the point of this is that you can compare various buildings within your, if you're looking at a multi-building site or multi-building locations across the country, across the world, across, you know, different buildings on campus, you can look at ways to evaluate that. So. So what I wanted to do, we've got a few more minutes. So what I wanted to do is see if anybody had any questions at this time on any of this, the material that you've seen. So. Sharon, have we got any questions?
Keith, yes, there are. If you check in the question section, there are, I think, about 3 questions in there. We've had some audio issues with a small number of people, but I think those are local issues because most people seem to be able to hear you. So some of the questions were related to that, but I've tried to take those out. So you should just see just the questions specific to your presentation.
Okay. Well, I've got.
I can read you the questions that I have.
Yeah, because
okay, we've got, are there any airports in the US that have Schneider's building analytics?
So from an airport perspective, I don't know because I'm not aware of all of the locations that we have our analytics activity. But if that's what I can do is do the research and have somebody get back to you on that. So one of the things that is sort of interesting about analytics packages, while I showed you ours, right? There's other people that have it and different people that do it different ways. You know, one of the things that we do utilize is the analytics is agnostic as far as what kind of building management system or energy monitoring system you have. It's strictly a standalone solution that provides data to the client, because I've seen it utilized using our own building management systems, and I've seen it utilized using other, various other building management systems. So it is very much a standalone solution on itself, and that would be true for any of the, for any analytics packages, I would assume, but it would be something that you can investigate. So. go ahead, Sharon, the next question.
Okay, we've got several questions coming in now, so please be
Okay.
patient if I don't get to your question immediately, so we'll work our way through them. The next one is, are you seeing increased use of analytics in colleges and universities?
So the answer to that question is yes, because what we see is a number of universities have older buildings. So I can give you an example. Locally, you have buildings that have been in place, since the 50s and 60s, and they're building new buildings right now. So you have this wide breadth of aging infrastructure, new infrastructure, and how do you manage and even compare across the various issues, right? Maintenance issues, energy efficiencies. So analytics allows that to occur, and in that campus environment. The picture I showed earlier on the map in Boston, that's what that was. That was a university campus. So it's very much being used in that application.
Okay, so then we also have, can it reset set points or only reads data from BAS?
No control. This is a one-way. It's providing information from the BAS into the software. It is not a controls platform. It is not going to change anything.
Okay. Next is, can the building analytics system tackle with equal efficiency both mechanical and electrical issues, or is it more appropriate for mechanical systems?
It's an interesting topic in that most of the building analytics activity is focused around the mechanical systems. While it can tell you if your energy usage, right, from an electricity standpoint, but it's not going to go tell you what type of maintenance you need to do on your switchgear, or what type of because those electrical infrastructure components don't have the as a basic and more complex systems. We still don't see a lot of sensors or data collection from that type of equipment. I mean, it can pull electrical energy data from energy monitoring systems and do some analysis with that, but it's not going to tell you how to do condition-based maintenance on circuit breakers. It's just that the data is not there for the software to do anything with. So the software wasn't designed to do that.
Okay, next question is, do you have any sort of demo or analytics for industry like oxygen plant, and then in parentheses, air cooling distillation process?
So that's a very specific topic. And so that's one we'd probably be better offline, because I'm going to need you to talk to somebody besides me to go into that specific an application. So if you have the name of the person that submitted that,
I can download those.
Yeah, we'll connect with you. If you have anything specific like that, just make sure that the question's in, and we'll work to get some specific information to you on that type of topic.
Okay, next we have, has this system been used for group senior living communities?
I know it's been used in condominiums, but I don't know if it's been used in a specific senior living application. So that would be,
okay.
we're going to have to, that's another one we'll have to do.
Okay.
Those specific applications, I mean, it's been done in a lot of commercial buildings, a lot of industrial buildings, and a lot of campus activity, and in hospitals. So when we're talking about a senior living, you're talking about a combination, if not specific to that, the same types of equipment.
Okay, the next question is, how do you group the buildings where they are in different locations across the country, different ages, different structures?
So what you would end up doing is when you start looking at building out we talked about building profiles, equipment profiles. This is where you would go in and build that out, right? So we're going to select what we're going to do. We're going to put in all of the equipment profiles for the specific building, and you would do that for multiple buildings, whether it's something in Boston, whether it's something in Paris, whether it's something in Lexington. You know, that's part of the when you develop that building profile, when you develop those locations as part of when you build up the data inside the software.
Okay, next question is, how is the data accessed?
So the question is, how is the data accessed? So if this is how the software is accessing the data, it is basically pulling data over the internet, right? It's a cloud-based solution that's a hosted solution, and so it's pulling where you have data points coming into your building management system. It could be pulling data right out of the database that your building management system has that's collecting all of that, right? So if you have a building automation system, it's got a SQL database or some type of database, Oracle, that's pulling and maintaining all of those that data, and then that's where the data is coming from, being pushed from there into or pulled into the cloud-based software.
Okay, next question is, how quickly would an alert reach the client?
Well, in this case, we're not talking about alarming. An alarming issue is going to occur immediately, and that's going to be out of your BAS. For a report on an issue that's being developed by the building analytics, that timeline is going to be, you know, depending on the type of analysis, how detailed the issue is, you know, you're going to have reports that could be, you know, the next day, that week, whatever that month, whatever the frequency is that you want from those types of reports. Because when you look at, you know, some type of an alarming, you're trying to do trending, right? You're trying to look at, are we having the same problem over time? So it's not trying to react to a very specific incident that's occurring. That's part of your immediate alarming through your building management system. I mean, if you want to get a daily report on certain aspects of your building, you can do that. That's just not because if you remember from the software, you had a report feature that would allow you to do the set your timeline for the report for a report you could generate yourself, or if you're using a client-based service where they're putting all of that together and sending you the report depending on what your capabilities might be and what you want to do with it. So it varies. That's going to vary a little bit based on what your individual need is. So the answer to the question is, in a certain extent, it depends on what you're looking for. But the answer is it's a wide variety of timing based on what you need. So.
Okay. Next question is, how tedious is the installation of the analytics system? Can they be installed on really old buildings, and does it involve installing multiple sensors?
So it depends on what you want to accomplish. So you can if you have any type of building management system that exists, then you can pull data from that building management system. What it's going to limit is what it can give you, right? So if you have a real old building that might only have a certain set of sensors or a certain set of controls, then that's what it can pull, right? And now if that's going to give you what you need to manage that building, that's good. If you want to improve, you can add additional sensors. But the sensors are really more for managing the building. So it's part of your building management control system, you know, to get better control of your building. The analytics is pulling that data to give you the timeline and to give you the analysis on what it's seeing from those various faults, whatever they might be. So so it can, as long as you have something there. I mean, if you have a building that has no building management system, has no automated controls, then something like this isn't going to help you, because you're not going to be able to put data into it for it to be able to do anything. So.
Okay, next, someone pointed out that they think there's something on one of your slides, on I think slide 10, there was a bullet point that you did not cover, but I'm gonna download this for you, so perhaps you can address that one directly with that person.
Okay.
And then the next one says, I didn't see in the charts and graphs any means to reflect set points, OAT or RH, along with the performance metric. Did I miss that?
No, it's there. I didn't cover them all. So, you know, one of the things, if there's something specific that somebody wants to go through the entire software to see what it can do, make sure we have your contact information and we'll take care of that. All right. I mean, I took roughly 30 or 35 minutes to try to give you a flavor of some of the stuff that's there. Obviously, you know, I couldn't show or give you a demonstration of everything. So.
Okay, someone says they recognize that the cost of the tool may vary for many reasons, but what is the price range for this tool?
Yeah, there's no when you start talking about that could be, I'm not even going to take a shot at it, because what you're looking at there is, are you looking at one building? Are you looking at a campus? Are you looking at buildings across the world? There's no way to take a shot at that. Your best opportunity there is to have a discussion around what you actually are interested in seeing, and then a rough guideline could be developed. There's no way I could do that. Not from here. So.
Okay, someone has asked, let's see, is there time at the end? Can we take another peek at the alarms tab? I don't know if you want to wait for that one.
What I'd rather do, based on where we are in our time, we're probably better off. I mean, I can show the alarms tab, but if there's something specific that somebody wants to see, would be better to probably take it offline. Okay. Because we're after our 45 minutes as it is. So.
No problem. Well, if anybody else has any final questions, go ahead and type them in. Even though we don't have time to answer them right now, I can download those and forward those to Keith. And then Keith can maybe address them, may even be able to group them together and address them in an easier way. Because we do have several that we have not got to. So I do apologize if we have not answered your question, but I will download them and send them on to Keith. And Keith, if you would please if you wouldn't mind showing your contact information again, if you're happy with that, right, so people can perhaps contact you directly also. That would be really helpful.
All right, so let's do a couple things. Let's do a couple slides here to finish up. So first off, I'm going to give a little bit of headline to the WEC, for the World Energy Engineering Congress, that's going to be in Charlotte here in about a month. For those of you that are planning on attending, I invite you to participate in Thursday's afternoon track for energy management for intelligent manufacturing. I'm actually one of the presenters during that track. Also, if you haven't looked at attending one of these events, I would recommend you look into it. If they're very worthwhile, and you learn a lot across the breadth of different type of activities, whether it's government, commercial, renewable energy, industrial, new technologies, all of that. So again, here we've talked about questions. Here's my contact information. Feel free to reach out to me, and we'll coordinate getting answers for anything specific that you might want to see. I will take a list of questions from Sharon, and we'll get answers put together and get those out. So.
All right. Well, at this point, I'd just like to say thank you, Keith, for your time and your expertise on this. We certainly appreciate that. Thank you, everyone, for joining us this afternoon. am currently recording this session, so I will download that recording, and once it's available, I will share that with everybody that was registered for the session. So you'll be able to see Keith's presentation through the recording if you'd like to view it again. So once again, thank you, everybody. We appreciate you joining us this afternoon. Is there anything final you would like to say, Keith?
Just I want to thank everybody for taking the time out of their day to listen and to get a feel for what we think is a trend in the industry in terms of building analytics and taking more of the data and developing solutions and to assist with developing return on investment actions. So again, to go develop actionable activity that will help meet the current objectives that we have for our buildings, no matter what type they might be.
Okay, finally, I'll just leave this. I'm going to mute myself, but I'm going to just leave it open for the last couple of minutes. So if you do have any final questions, you have about just a minute or two to just go ahead and type those in before I download those questions to forward them to Keith. So once again, thank you, everyone, and I hope you can join us next month.